Feis.
Yep. It will capture everything that's on here, and then what's here.
So does everyone have? So I know we're struggling with the data download. I apologize for that. But does everyone know how to set their working directory once they have those files downloaded?
Oh, I can show from the beginning.
Okay. Yeah, that would be great.
Yeah. So so I will talk first, and I will talking about the R plotting using a package called ggplot. So if you haven't do this, so please open the R code called R underscore tutorial plotting. So everyone is in that page. So probably you will do as fast as me. See, for example, this is a long sentence, and you need to roll this bar to see the whole sentence. So anyone has a problem? What I want to do is first you go to the tool under the global option, and you can see in the code. You can see under the general option there is a software rep R source file. So you have this check and click OK, and you will find out that all your code is represented in a better way. So if you haven't set up your working directory, so just go to the session, and in the set working directory. So basically, I save my data file in the same folder as the code, so you can see the two source file location. And then your working directory is where your code located. Everyone is in the same page as I? Okay. So here I will talking about 5 things here. One is plotting histogram, and the box plot, and the point plot, and line plot, and the 5th is bar plot. And in the end, I will show a quick way to how to arrange your different figures in the big one. Okay. So if this is your first time using R, so you may want to install the packages that we're talking about today, called ggplot2. So run the line 16. So for now, I have installed it in the computer. So I will just skip this step. But if you haven't, you should do this. Okay, then we come to the line 19. Okay. Then we come to the line 19 to tell R that I'm going to use the ggplot in the following codes. So use the library function, and that is even more important than the last code. So run the library.
You have to do that if you want to use any new package that you download?
Yes, I think.
There are some packages that are preloaded in R. So, Faye, can you click on the packages in the bottom left? So those are preloaded, but you still have to add them to the library. But if they're not preloaded, then you do have to do that first install .packages. So if you do library, whatever the package name is, and it doesn't come up, then that means you need to install .packages.
And once you've installed, then you don't need to do library?
For that session. When you reopen R, you have to do it again.
Yeah.
It doesn't have memory that it will just automatically load everything each time that it loads.
Also, it is safe if you could run the library function every time you open R. Yeah.
It should really for probably us, the library function is the first couple lines every time we ever open R.
So next line in the line 26, we are loading the data from a file. So in the code, I said the data file's name is fee_data.csv. But I think when you download your data file, it is automatically added some sort of letters at the end of the file. So I think you may want to change the file's name from Feis_data to that. So and you can run this command to see if everything is working. Yeah. Yeah. Take care. Yeah. And include that 2NT H G 9W. Yeah, and run that. No, you don't click yes. Just yeah, you don't have to stack. See, yeah, it's okay. So in this line of code, so it's called the function is called read CVS. Apparently, it's reading CVS files, and there is an argument here called header. Header means whether the first row of your data is the name of the column rather than the data. Okay, for instance, if we check the R data, then we just load it. You can see like the first row in the CSV file is actually the name of each columns. It's not a data record. So in that case, you may want to say the header is true. Everything is okay? Yeah. Okay. And then we want to the header. Okay, the header is that if you go to your if you go to the CSV file, the first row is actually not a data record. The first row is the name of each column. Just this is like a quick example. Okay, not here. Wait a second. This is a bad example. Where a oh, wait a second.
There is a header on that, it's just pretty hard to see, but yeah, that's a better example.
Yeah. So oh my god. Wait.
Sorry, not so much crap.
Okay, the header means okay. See the first line. First row of the data is ID, horizon, sand, clay, and order. This is not a data record. This is the name of the data. So the header function means does your data has a header? So in that case, yes, we have.
Yeah, and so if it didn't have the header, the first row where you see 1 would actually be like ID, horizon, sand, instead of it being above the first row.
So what T stands for?
It's
What?
true. Header
T.
equals true.
True versus F false. Okay. So let's just look into the data a little bit. So there is a function that you can look the first 6 rows of the data called head. So if you run the line 30, in the bottom window, you can see the first 6 records of your data. And you can also like click here, just a single click your data's name, and it will pop up a window to show the whole data set. So we have 1, 2, 3, 4. Okay, yeah, we have 5 columns here. So the first column means the ID of the sample, your sampling ID, and the second, these are all soil samples. So the second column is horizon. It means soil layers, which has like A, B, C. Everyone knows. And the sand is a coarse particle, and the clay is a fine particle. And the last column is order. It's kind of soil type. So in this data set, I only have like two soil orders. One is called molly soil, and another is called office soil. Those are like two soil types. And at the bottom of the window, you can see like how many entrants you have in total. In that case, we have over 2,000 entrants. So that's the data set. And now we are going to plot our data. So the first plot I want to do here is a histogram to see the distribution of your data. I think it's important because a lot of statistics are based on assumption that your data is normal distributed. So it is really important to make sure that you have the right data. So the first I want to do like a very simple histogram with all the default setting. Line 33. So if you run this line, so I first call the ggplot function, and sorry, and I in the argument called data, I tell the function that okay, the data set I want to plot is called r.data, which we just look into, and which variables I want to plot. You can see there are ID, horizon, sand, clay, and order. So you have 5 variables. Which variable you want to plot? I want to plot sand. And the plot I'm looking for is histogram instead of any other plot. So this is just a very, very simple line to show and histogram. So run this 33 line and the next line. Okay. Okay, so in the right bottom corner you can see a plot. I've run it in that step. Okay, just look into the picture a little bit. It is not normal distributed, of course. So the x-axis is a sand content from 0 to 100%, and the y-axis is the count. So how many data fall into the single bar. So this is the count with all default settings. And so okay, and the color of this bar is just a default setting, like a dark gray, which is not very I don't know, beautiful or good looking. So what I want to do next is I want to fill the color into each bar, and I want the color to indicate how many data is in that bar. Like so here in the line 37, I made another histogram with additional argument called fill. Fill is just mean in which way you want to color your bars. So in that case, I want to color my bars according to the count, to the y-axis. So let's just run line 37 and on line 39 to show the histogram too. Okay, wait a second. Anyone get this picture? So,
Might just take it off. Sorry.
So basically the same y and same x-axis with the formal picture, but now we have the colors. So the dark color means we only have a few samples, like here, the dark colors, and the bright color is like indicate okay we have many samples falling in the bar, so which give you more direct information. So okay, as you know, see how wide of your bar also influence the appearance of this picture. I don't know. This is kind of a statistical concept. Okay, for wait a second. For example, the defaulting is like 30, which means the width of the bar is probably 30 or 3. So maybe this is like 0, 0 to 3, 3 to 6. It's like how many samples that with a sign content from 0 to 3. And you can change it like I want some detailed information. So I want to see like 0 to 0.1. Or I want some loose information. Like I want to see 0 to 10 to 20. So here, this argument bandwidth is going to set how wide your bar is. So currently I put it into 1. So let's just run the 42 to 44. It takes a while. See the bar becomes much narrower than before. Okay, if you can play with this argument. For example, I change 1 to maybe 5. Okay, to see what happens. See, okay, this is a width of 5. Means with my data range is from 0 to 100. So we plot every 5, so we totally have 20 bars. If you set it to 1, it's like you will get 100 bars. So I just put it back to 1. See, this will give you more details information. And another thing I want to show next is so currently the y-axis is a count number, means the actual number of data falling in each bar. So and also you have other options to set the y-axis as density, which means the number divided by the total number of a data set. So instead of the count, you will see a percent. So in the function here, the argument y is going to set up what value you want to plot in your y-axis. So the default is count, but now I change it to density. See, the shape of everything is the same, but the only thing changed is the density. Instead of the count, which up to like over 100, we have like percent. Okay, here's another thing I think might be useful, histogram 5. Okay, so this is a badly normal distributed data set, which is just not normal at all. So just imagine you have a kind of normal shaped data set, and you want to tell the readers or tell your audience how well it is fit to the normal distribution. So you probably want to add a curve to show that, okay, with that mean value of my data set, with the standard deviation of my data set, there is an ideal normal distributed curve, and how the actual bars fit into the curve. So here, like in the histogram 5, I want to add the ideal normal distributed line to the plot. So the function to do this is called stat underscore function. See, so the first argument here is to tell, okay, I want to add a line. That line is the density of a normal distribution, and the color is red. And I want the mean value of this line is the mean value of my data set. And I want the standard deviation of this line is the standard deviation of my data set. So let's just run 53 to 55. Okay. See, here is the red line. Okay, the mean value of the red line is the same with your data set, and the standard deviation of your red line is the same with your data set. So again, this is not normal distributed. But if you have like a general normal distributed data set, you can see that clearly how well they two like fit each other. And so this is at a like statistical line to our figure. And another thing I want to tell is how can you like utilize those empty space in your plot? How can you add some maybe words or something you want to explain to the reader? Like in this case, I think it's pretty normal. See, people reading a paper, they want to, oh, this is your distribution histogram, and they want to see, okay, how many data you have in total, what is your mean value, and what's your standard deviation. So it will be great if you have like a little text explaining everything, explaining the actual number here. So the next, So the next function, annotate is to add text to your plot in anywhere you want in that plot. So if you are looking at line 60, the function annotate. Okay, so the first argument is to tell the function, okay, I want to add some words, text. And then the x argument and y argument is to tell where I want my text, what is the position of my text. For here, the x value is 75, 75, 75. What does that mean? And the y value is, okay, also 3 numbers. It means that I want to have like 3 groups of words. And the first location I want to, the first location is like 75 and 0.050. Like 75 in x-axis, and 0.1 or 0.015 is sort of here. So that is where I want my text to be, the location, the position. So if we run the line 59 to line 61, everyone got there? So again, I want to add 3 groups of words, and their content is mean, standard deviation, and count. Like in your case, in the actual case, you want to replace with the question mark with actual data, actual number, and I want the position, okay, to be in a column, so they share the same x-axis, x value, and I want some space between them, so I set my y position value. So so here, like, you have the data number and you have your plots. So this kind of histogram that will give you a lot of information than just several bars. So next in the histogram 7, so I want to like keep working on my plot. For example, I may want my the title of my access to be maybe signed content with the unit, and I want the font to be bigger so people can see clearly. So the next argument called theme in the line 67 is to like set a name and the font of your X, Y labels and the text. So if you run histogram 7, which is line 64 to line 68. Wait a second. Okay, you can see the main part is still the same, but here you have more prettier titles with a bigger font, so people can see clearly. So that's the idea of histogram. And okay, the second plot I'm talking about is box plot. Okay, for example, like I want to see the sun distribution across different soil orders with soil types and in different horizons. What is the maximum value? What is the median value? And the the minimum value. So here is also a very simple code to check the sun distribution across different soil orders or classes. And so I tell the function ggplot that I want to plot the R data set, and I want to plot the sand content distribution, and I want to see the distribution across different orders. So that's the x-axis mean. You just run the code line 75 to line 77. Okay, so this is the two soil orders I have. This is their sand content, and this upper this the top means the maximum value, and the bottom means a minimum value, and this is the mean. This is the median value. This is 25 quantile, 75 quantile. Okay. And also you can clearly see, okay, that soil type kind of have a slightly larger value than that set. Okay, again, so, and the next one, so here we can see I only compare different orders. It means different soil types. What if you have here? What if you have like two like classification variables? One you can see different horizons, and you can also see different soil types. So the box, the box 2 is looking to the sand distribution across different orders and different horizons. So another argument you want to add is a fill, means the color of your of this box. I want to color those boxes according to their horizons. So just run the 80 to 89. 80 to 82. Okay, so in that, so that picture basically means, okay, in each of those soil class, we have 3 horizons, which means shallow to depth, to deep, and then you have like 6 groups in total. So yeah, so that's way you can kind of compare a variable across like with 2 criteria. So again, this box 3 is to further adjust the font of your y and x axis to just make it beautiful. It doesn't add any new information. So in that way, it's like much clearer.
Are circles, are those outliers?
Yeah.
Potential outliers?
Yes.
Okay.
So sorry. The circles are potential outliers.
The legend gets added automatically.
Yes. You mean the legend? Yes. There are also like functions to adjust your legend. You want to maybe remove it, or you want to remove the title of your legend, or you want to adjust the location of the legend, right, bottom, or top. Okay, so again, the box the box 4, I also want to add some words or text at the top of this each of those boxes. Why I want to do this? I think some people want to talk about the ANOVA test in the following lectures, right? So it basically tell you, okay, like whether those two data sets are significantly different from each other. Like maybe in statistical, if that one is like 0.1 lower than that one, then you think, okay, that's not significant enough. I think they're basically the same within arrows or uncertainties. But if that one is like 100 lower than that one, or I will think that is not something error or uncertainty. So what ANOVA does is it will use like English letters to indicate if those data sets are the same or different. So for example, if you run the line 91 to 93, which is box 4. Okay, you can see I added one letter on top of each of those boxes. So in your real application, it's not going to be all A's. Maybe it's like A, B, A, B. Like A and A are the same. A and AB are slightly different. But A and C is like totally different. So that's basically how it works. So you can label it, okay, to show that, okay, A horizon and B horizon do have significantly different sand content. Okay, that's a common application of the box plot. And so now the point plot or scatter plot is to show the relationship between two variables. So in my data set, okay, I have sand, I have clay, and typically they have like negatively correlated with each other. Higher sand, you will end up with lower clay. So I want to plot them. Okay, it is also a simple code to use all the default settings. You just to tell the code, your y-axis will be going to be the sand, and your x-axis is going to be the clay, and you want the point plot. So just run 99 to 101, line 101. Okay, so here is the plot you get. Okay, basically negative correlated with the default black colored points. And then in the next plot, the scat2. Okay, just further adjust the color, the size, the color, the size, and the shape of your plot. So here, actually, the color is red, and the size is 2. You can play with the number to see, okay, how big is 2, how big is 4, and the shape is 4. It's kind of weird that they use numbers to indicate different shapes. Like for 4, it's like crossings. You can also change it to different shapes to see what's going on. So this is an adjustment to all your points. Okay. So here, so I want to plot the relationship between sand and clay to group the point by other factors. So for example, here I have different horizons. I may want like the C horizons points to be all black, and the A to be all red, and the B is blue. Also, I can see which plot is in which horizon. So here, just run the code 109 to 111. Okay, so you can see here, okay, I have 3 different shapes of points. The circle, yeah, the circle is A horizon, and the triangle is B, and the square is C. And also, I have two colors indicates different classifications. So in Okay, so in that case, okay, here is a point here. It is square, so it is C horizon, and it is blue, so it is horizon. So you can tell from the plot very directly other information about the point rather than the sand and the clay content. Here I use the different colors and different shapes to indicate like different grouping method. You can also play with the size. Okay, so if I, for example, if I change the shape to size, you don't have to do this. Okay. Okay, it may hard to see, but you see, the A horizon has the smallest point, and B have the middle size, and C the largest. So you can still tell from the plot. Okay. It's stuck. Wait a second. Okay. Yep. Okay. Okay. Again, the last thing we want to do is to finalize your plot to set a like x theta that means something to you. For example, I want my x-axis to be the clay content percent, y labeled as sand content, and I can further adjust the font, the color, or the size of the title. Okay, wait a second. Oh, I think I need to restart something. I'm sorry, but all my variables are gone, so I may need to work further on it. Can I see? Just give me 1 second. Where is the folder you?
That's really weird.
Yes. So, okay. Your light's not refreshing. Okay, here we go. See, that is what's going to happen if you didn't run the library function first. It will could not find the function. So which means you should run it first. Yeah, okay. Here we go. Okay, so that's the point plot that we finally end up with clear and meaningful labels, and colors indicates different soil orders, and the shapes indicate different horizons. And we can also see the negative relationship between sand and clay. So that's a point plot, and then we have the line plot, which is also basically related with the time series data. Okay, to see a variable change with time. So here I create a new data set, a data frame to plot. Okay, so just run the 123 to 128. Everyone is on that. So here is a new data set that I created called series data. So if you look into the data on the right, or you can look into the bottom of your window. So it has like 4 variables. The first one is time. So from 1 to 100, and the value of your 3 variables, which called variable 1, variable 2, or variable 3. So these are like any variables that are changing with time, and you want to plot it with line. So so the first one is just default with all default setting to see how the variable 1 change with time. So it is line 131 to 133. See, the y-axis is a variable 1, and the x-axis is time. See, they have patterns with time. So the color is red, as I said. And then the following code just to show you how to refine everything with the label. So nothing new. Okay, you see just nothing new information, just make it better to look. Okay, now here we only plot one set of data, variable 1. What if you want to plot variable 2, 3, or even more data according to your occasion in the same plot? So here, in the line 144 is when you plot the first variable, and the line 45 and line 46 is when you add new variables. So here I want to mention the argument color. You can see I didn't color it like gray or blue or a color's name. I color it like just a text, because a lot of times you don't care which one is black, which one is red. You just want them to be different. So, and you don't want to remember the colors of names, you know. So you can just give them different different numbers, different values, and the R, the function, will interpret. Okay, I don't know what it is. This I don't know what it is, but I know that different. So they will give you 2 different colors. In this case, 3 different colors. So you just run 143 to line 147. Okay, so that's your label. That's your 3 variables in 3 different colors, and that's your plot. Okay, the next thing I want to show is, okay, here we only have 3 variables, so it's fine that for each variable you edit a new line here. Until I want a new set of data, so I tell what is x, what is y. So just imagine like you have 100 or even more variables. You don't want to repeat this like manually, so you want to like automatically handle it. So that's the next thing I want to show you. So before we do this, we just look into the data itself. So we have 4 columns: time, variable 1, variable 2, variable 3. And what the next function did is that it like reshape those data set in a new form that you can plot the line according to different series automatically. So the function is called reshape. So again, you need to library reshape to where the function is located in. And then you run the line 152. So you transfer the dataset named series.data into a new name called series data long. Just to give it a different name. So the function here is called melt, and I will explain what ID means like later. So just run the 152. Okay. And in the right window, you could see your new data frame series data line. Okay, just click it to see what it does. Let me see. So here is still your time. We actually originally we only have like 100 time steps and 3 variables, but now we have kind of 300 entries. And okay, if you compare the data series long with original data set, you can see this long data set just combine everything here into one single column value. So if you without this column, okay, if you don't have this column called variable, you couldn't tell this value. I know the time step, but I don't know it is variable 1 or variable 2 or variable 3. So that new column here is to indicate which kind of series this data is from. Okay, so in that case, like we can plot the line data automatically. If you see the argument in the line 156, you can see here the axis, x-axis is time, sure, and the y-axis is the value. And I want to color it according to the variable. Like different variable value have different color. So if you run the line 155 to line 157, it's basically the same as you did it manually, but in this way just faster, especially when you have like 100 series of data. And the next thing I want to do is to further adjust the legend. As I said, you can remove the title of your legend, and you can adjust the position of your legend. So here it don't have a title, and it is on the bottom of your plot. And the last thing I will mention briefly is the bar plot. So again, I create a bar data. Okay, quickly look into it. It's just like 5 entries with time variable 1, 2, 3. And first you want to plot the value of variable 1. Here is the value. And if you want to okay, so if you want to plot like 3 variables in the same plot, you need to kind of redo the processing process of the data again to do it manually. So the code is pretty much the same with the line data. How do you process a data set? So you can plot it manually. And the last thing I want to cover is that for example, you want to save this plot into a separate I don't know, a PNG or JPG file. So you can click Save Image. And how about you want like 4 or even more plots in one big file, and you don't want to do it manually. So you want to R do it for you. So there is a library called Grid Actor. So we load it, and it will arrange several figures into one big file. So if you run that command, in the last line, it may take a while. Okay, box 1. I need to redo it. Give me 1 second. Okay. Yep, it takes. It takes some time to show it. Okay, here I do is see there are 3 plots that we just did, box 1 to histogram 2, and I want to arrange it into like 3 columns and 2 rows, so you have like 6 pictures in one big. Okay. Did anyone see the results of it?
Yeah, mine just came up. It took a while.
Yeah. Okay, here we go. So those are just random 6 of all those plots that we plot in the formal code, and you want to put them together into a big one, so you can save all 6 of them at one time instead of collect like for 6 times. So that's the way you can arrange like single plot or big one. So that's basically what I am doing with the ggplot in R. Yeah. If you want any other codes, you can talk to me. I have extra codes that I can share.